NEC 605.6 requires that multiwire branch circuits supplying power to a partition shall be provided with a means to disconnect simultaneously all ungrounded conductors at the panel board where the branch circuit originates. This requirement aims to prevent the possibility of a fault on one ungrounded conductor from affecting the other ungrounded conductors on the same circuit. It's understandable that you're looking for a way to disconnect 4 or 5 breakers simultaneously, especially considering that office furniture is often provided with either 4-circuit 8-wire or 5-circuit 8-wire configurations. While some manufacturers provide handle ties to trip up to 3 individual circuit breakers, there are alternative solutions to achieve the simultaneous tripping of 4 or 5 breakers. Let's explore the available options in detail. Firstly, consider Eaton's breaker tie. Eaton offers a product called the breaker tie, which is a mechanical interlock. This interlock can be installed on up to 6 circuit breakers. When the breaker tie is tripped, it will simultaneously trip all of the circuit breakers that it is connected to. This solution directly addresses the need for simultaneous disconnection of multiple ungrounded conductors. Secondly, multi-pole circuit breakers are an option. Multi-pole circuit breakers are specifically designed to trip all of their poles simultaneously. This type of circuit breaker is typically used in applications where it is necessary to disconnect all of the conductors on a circuit at the same time. They are available in configurations that can handle the required number of poles for your application. Finally, remote trip units offer another possibility. Remote trip units are devices that can be installed on circuit breakers to allow them to be tripped remotely. This type of device is typically used in applications where it is necessary to trip a circuit breaker from a location other than the panel board. They can be configured to trip multiple breakers simultaneously upon receiving a signal. When selecting the appropriate solution, several factors should be considered. Firstly, compatibility with your existing panel board is critical. Not all panel boards are compatible with all of these devices. It is imperative to consult with the manufacturer of the panel board to determine which devices are compatible. Secondly, the specific requirements of your installation must be taken into account. Consider the number of circuits that need to be disconnected simultaneously, the available space in the panel board, and the desired method of operation. Thirdly, the cost of each solution should be evaluated. The cost of each of these solutions will vary depending on the manufacturer, the features, and the complexity of the installation. Fourthly, ease of installation and maintenance should be considered. Choose a solution that is easy to install and maintain to minimize downtime and ensure long-term reliability. Fifthly, adherence to relevant codes and standards is essential. Ensure that the selected solution complies with all applicable electrical codes and standards, including NEC 605.6 and any other relevant requirements. Additional technical considerations when evaluating these options include the interrupting rating of the circuit breakers. Ensure that the circuit breakers have an interrupting rating that is sufficient for the available fault current at the panel board. The interrupting rating is the maximum amount of fault current that a circuit breaker can safely interrupt. It is typically expressed in amps. Using circuit breakers with an insufficient interrupting rating can lead to equipment damage or even personal injury. The voltage rating of the circuit breakers is also an important consideration. Ensure that the circuit breakers have a voltage rating that is compatible with the voltage of the circuit. The voltage rating is the maximum voltage that a circuit breaker can safely handle. Using circuit breakers with an incompatible voltage rating can lead to equipment damage or failure. The amperage rating of the circuit breakers must also be correct. Ensure that the circuit breakers have an amperage rating that is appropriate for the load that they are serving. The amperage rating is the maximum amount of current that a circuit breaker can safely carry. Using circuit breakers with an incorrect amperage rating can lead to overheating, equipment damage, or even fire. The type of circuit breaker is important. Different types of circuit breakers are available for different applications. For example, some circuit breakers are designed for use in residential applications, while others are designed for use in industrial applications. Ensure that you select the appropriate type of circuit breaker for your specific application. Finally, the listing and labeling of the circuit breakers and related devices must be considered. Ensure that the circuit breakers and related devices are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. Listing and labeling indicates that the products have been tested and meet applicable safety standards. Regarding the installation process, it is always critical to follow manufacturer's instructions. Carefully follow the manufacturer's instructions for installing the selected solution. Improper installation can lead to equipment damage, safety hazards, or code violations. Only qualified personnel should perform the installation. Electrical work should only be performed by qualified personnel who are familiar with electrical codes and safety practices. This will help to ensure that the installation is done safely and correctly. Inspections are necessary to verify that everything meets code requirements. Have the installation inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and standards. This will help to identify any potential problems and ensure that the installation is safe and reliable. Regular maintenance is also essential for continued safe and effective operation. Implement a regular maintenance program for the circuit breakers and related devices. This will help to ensure that they are operating properly and that any potential problems are identified and corrected before they lead to equipment damage or safety hazards. Some additional points to consider include arc flash hazard analysis. Consider conducting an arc flash hazard analysis to determine the potential arc flash hazards associated with the equipment. This will help you to select appropriate personal protective equipment, or PPE, and to implement safe work practices. Coordination studies might also be needed. Perform a coordination study to ensure that the circuit breakers are properly coordinated with other protective devices in the electrical system. This will help to minimize the extent of any outages and to prevent equipment damage. Surge protection may also be necessary. Consider installing surge protection devices, or SPDs, to protect sensitive electronic equipment from voltage surges. Voltage surges can damage or destroy electronic equipment, and SPD can help to prevent this. Training is also important to remember. Provide training to all personnel who will be working on or near the electrical equipment. This training should cover topics such as electrical safety, arc flash hazards, and safe work practices. Documentation is always important, so keep accurate records. Maintain accurate records of all electrical work, including installation, maintenance, and repairs. These records can be helpful for troubleshooting problems and for planning future work. Finally, consider future expansion. When selecting a solution, consider the possibility of future expansion. Choose a solution that can be easily expanded to accommodate future needs. Staying updated with the latest NEC requirements is important. The National Electrical Code, or NEC, is updated every 3 years. Stay up to date on the latest NEC requirements to ensure that your electrical system complies with all applicable codes and standards. Consulting with a qualified electrical engineer is crucial. Consult with a qualified electrical engineer to ensure that you select the appropriate solution for your specific application. An electrical engineer can help you to evaluate your needs, select the appropriate equipment, and ensure that the installation complies with all applicable codes and standards. By considering all of these factors, you can select a solution that will safely and effectively disconnect the ungrounded conductors in your multiwire branch circuits. This will help to protect your equipment and personnel from electrical hazards.